In this video, we're going to take a look at some intermediate metric conversions. We had a previous video that looked at basic metric conversions where we just looked at kilo and milli, and it introduced the factor label system. And then we just did some base unit conversion to milligrams and kilograms. So if as we go through this video you have a little bit of trouble following it, you can just go back and watch that previous video. I'll put a link to it up in the corner there. This video is listed as an intermediate difficulty level video because it does assume that you have some previous knowledge. It assumes that you do understand how to do the factor label method and that you at least are somewhat familiar with the base metric units of a gram, liter, and a meter. So let's get into what we're going to take a look at today. The first thing that we want to do is take a look at the large metric prefix chart, make sure we understand how that works, and then we'll do some practice problems converting on the metric chart. So here we have the metric chart here. And what this shows us is in the middle, in blue, we have the base units, so a gram, liter, and a meter. And then everything above it is larger, and everything below it is smaller. So if we take a look, everything above the base unit is larger. And then everything below the base unit over here is smaller. And as you go up the scale, everything gets larger. So if we take a look at 2 units, let's say we take a look at the giga unit, and then we compare that to the hecto unit. The giga unit is larger than the hecto unit because it's higher up in the scale. We take a look at 2 other ones. Take a look at any base unit and a centi. We see that the base units are larger than the centi. How much? The base units are labeled as a factor of 1, and the centi units are 100 times smaller than the base unit. Take a look at just one more example. Again, we could look at the base units, and let's say we go all the way up here to tera. Which one's larger? Tera is larger because it's higher up in the chart. How much larger? Well, the base unit is the factor 1, and a tera is 1,000,000,000,000 times larger, or 10 to the 12 times larger than our base unit. So let's take a look at some practice problems that will utilize this chart. And in today's problems, we're going to go from a non-base unit to another non-base unit, which tends to give students a little bit more trouble than going from a base unit to a base unit. What I mean by a non-base unit to another non-base unit is, let's say that you're starting off with a giga and you want to convert into kilos. So the giga is a non-base unit and the kilo is a non-base unit. So students tend to have a little bit more trouble doing those conversions when there's not a base unit involved. We're going to, again, use the factor label method, and I'm going to show you a fairly easy technique to convert from non-base unit to non-base unit so that you have the least chance of messing up on the conversions and adding in extra zeros or leaving zeros out. So I'm going to leave this chart up so that we can kind of use it as a reference. I'm just going to shrink it down a little bit, but we'll still leave it up there. And then let's take a look at the first problem. So this says if you have 0.78 megameters, how many hectometers do you have? The first thing that you're going to notice in this problem is we have megameters and hectometers. Neither one of them is a base unit. We are converting length because we're working with meters. So this is a length conversion, and you're starting with one non-base unit and converting to another non-base unit. So let's see what that looks like on the chart there. So we're going from a mega unit, and then we're converting it to a hecto unit here. Now, I don't know how a mega and a hecto are related to each other, but I do know that a mega is 1,000,000 times bigger than the base unit, so I'm going to convert from the mega to the base unit first. And then I know that a hecto is 100 times bigger than the base unit, so I'm going to then go from the base unit to the hecto. So anytime you have a problem where it has two non-base units, what I always suggest doing, especially if you're relatively new to conversions, is to convert to the base unit first and then go from the base unit to whatever unit it's asking you to find. And basically what it does is that breaks larger problems down into two smaller, simpler problems. So let's try that using the factor label method. So it says we have 0.078 megameters, 0.078 megameters. And then using the factor label method, we're going to draw our line here for our conversion factor. Right there. And we want to put the unit that we want to have cancel out on the bottom, so that would be the megameter down here. And the unit that we want to end up with, again, we're going to the base unit of meter, so we'll put that up at the top. Now, what is the relationship between a megameter and a meter? Well, if we take a look, the meter is right here, that's the base unit, and the megameter is up here, and that is a billion times the size, a million, I circled the wrong one. The megameter is a million times the size of the base unit. So which one is larger? That's the first question that you have to ask. Well, the mega is larger than the base unit. So the larger one, the big one, gets the 1. And then we take a look, well, how many times bigger is it than the meter? Well, based on that chart there, it's 1 million times bigger. So we put a million up here for the meter. And now we see that we have it set up so our megameter and megameter cancel out so that we're left with just meters. Remember, we multiply across and then we divide up. And again, if you're not familiar with the metric system or not familiar with the factor label method, or you're having trouble with it, go back and watch the previous video. And that kind of explains the basics of how to do the factor label method. So if we take 0.078, multiply it by a million, and then divide it by 1, we will get 78,000. And the units on that are going to be meters. Now that's not the final answer. That is just converting the megameters into meters. The final answer we want to get into is hectometers. So now what we're going to do is we're almost going to set it up like another miniature problem. Now we need to do the second part of the problem where we go from our meters that we've converted into and convert that into hectometers. And we can see that that's a 100-to-1 relationship and that the hecto is the larger unit. So let's set that up as another problem. Now we're going to start off with our 78,000 meters. 1,000 meters. Draw our conversion factor line, put our parentheses in, put the unit that we want to cancel out on the bottom so they're diagonal. That's the meters. And then the hectometer will go up on the top because that's what we're going to be left with, hectometer. And now you just have to ask yourself, okay, which one's the larger unit? You can see the hectometer is higher up in the scale. Hectometer is up here, whereas the base unit is down there. So the hectometer is the bigger one. So you put that as a 1. And then the meter, how many times bigger is the hectometer than the meter? Well, we can see on the table here, it's a 100 times bigger. So we put 100 down here. It takes 100 meters to equal 1 hectometer. All right, now we have it all set up. So meters and meters will cancel out. And then we just do the same thing we've always been doing. You multiply across. And then you just divide up. So if we take 78,000 times 1, that gives us 78,000. And then we divide that 78,000 by 100, and that will give us 780. And that answer will be in hectometers. So now we have our final answer as 780 hectometers. And that is the final answer for the problem. So if you have 0.078 megameters, it is equal to 780 hectometers. And you can see rather than trying to do it as one large problem, if we did it as one large problem, we would have had to seen how this mega and hectometer interact with each other and use them as a conversion factor. And it's possible to do that in one step, but I find that students that are just learning this have trouble going from non-base unit directly to another non-base unit, and it's a lot easier for them just to go from non-base unit to the base unit and then base unit to whatever they're being asked to find. Okay, so that's one example of non-base unit to non-base unit metric to metric conversions. Let's take a look at a few more to make sure that we're comfortable with the process. So clear everything off of here. And the next problem that we're going to take a look at, we'll drag it out here, has us going from decigrams to micrograms. So it says if you have 8.2 decigrams, how many micrograms do you have? Again, a good thing to always do in these problems is, okay, first thing just to ask yourself, what units am I working with? What am I measuring here? Okay, well, we're measuring mass because we're looking at grams. Okay, so we're measuring mass. All right, am I working in the English system or the metric system? Well, you're working in the metric systems because these are metric units. Deci and micro are metric units. Okay, am I going from a base unit to a non-base unit, or am I going from a non-base unit to another non-base unit? Well, since there's a prefix in front of both of these, you're going from a non-base unit to another non-base unit. Those are all good things to know before you start off so that you just at least have a very good understanding of what to focus on and how to approach the problem. So let's take a look. We're looking at a decigram, so that's this one down here. And it's asking us to convert the decigram into a microgram, which is this guy down here. So again, I don't know the relationship between a deci and a micro, but I do know the relationship between a deci and the base unit. So that's the first thing I'm going to do is I'm going to convert the deci into a base unit. And then I'm going to convert the base unit of grams down into micrograms here. So we're again going to break this into a two-step problem. So let's take a look at the first step. We're going to go from decigrams to grams. So we have 8.2 decigrams. And again, we'll set up our conversion factor line here. We'll put grams on the bottom, or decigrams on the bottom, so that they cancel out, and grams on the top. And then we need to know, okay, well, how are they related to each other? So decigrams they are related to each other by a factor of 10. Well, you have to ask yourself, which one is the big one? Well, the one that's higher up on the scale is the base unit. So the gram is the larger one, that's the big one, so you put a 1 there. The decigram, how many times smaller is it than the base unit? 10. So we put the 10 down here. Then we can see the decigram and the decigram will cancel out. As before, you just multiply across and divide up. So we take 8.2 times 1, which gives us 8.2. And then we divide 8.2 by 10, and that will give us 0.82. And the unit that it's going to be is grams because the decigrams canceled out. Now again, that's not our final answer. Our final answer, they're asking us to get into micrograms, but now we've at least got it into the base unit. Now we just kind of look at this as another simpler problem where we just go from the base unit of grams into micrograms. So now we're starting with 0.82 grams. We'll draw our conversion factor line, put our parentheses in, put the grams on the bottom so that it cancels out, and then we'll put our micrograms on the top because that's what we're going to end up with. Remember, always put your units in. If you don't put your units in, it's very easy to get confused with what you're ending up with. So now we need to take a look, okay, well, how are grams and micrograms related to each other? There's grams right there. And then micrograms is down here. So they are a millionfold different from each other. Micrograms is 1,000,000 times smaller than a gram. So you have to ask yourself which one is the bigger one, which one is the bigger unit. Well, that's going to be the gram because it's higher up on the chart. So for gram, you put the 1 because it's the big one. And then the micrograms is 1/1,000,000th the size of that. So up here is where you put your million. So if we want to convert from 0.82 grams to micrograms, we first then need to multiply across. So we'll take 0.82 multiplied by a million, and then we'll divide our answer by 1, which will give us whatever our answer was when we multiplied them. So if we take our 0.82 and we multiply it by a million, we come up with 820,000. 820,000. And the unit on that, because grams and grams canceled out, we see grams and grams canceled out, the unit on that is going to be micrograms. And that is our final answer. So if we were asked to convert 8.2 decigrams into micrograms, it would be 820,000 micrograms. Now I got one more practice problem that I want to talk about, and this one really takes you really large swings on the metric scale, and it's also going to kind of introduce a new topic to us, which is scientific notation, and that's ways to write either really big numbers or really small numbers in more convenient ways. So we'll kind of bring that in as well. But let's take a look at this last problem. It actually goes all the way into nanometers, and nanos are billionths of the base unit. So this problem here says if you have 300 or 734,000 nanoliters, how many decaliters do you have? Again, the first thing you always want to ask yourself is, okay, what am I measuring? Well, you're measuring volume. Remember, liters is a volume unit, so we're measuring volume here. Then you want to ask yourself, well, am I measuring English units or am I measuring metric units? Well, remember, the metric units are grams, liters, and meters. So since you're working with liters, this is a metric conversion. And then the last thing you want to ask yourself is, am I going from a base unit to a non-base unit? Or is at least there a base unit involved here? Well, no, there's not, because you're starting off with something that has a prefix, nano, and you're ending with something that has a prefix, deca. So now we at least know that this is a metric volume conversion problem, and that we're not starting with a base unit and we're not ending with a base unit. So it's a non-base unit to a non-base unit problem. Now that we kind of know all that, we can kind of get started. First thing we want to take a look at is where are we going to be going on this chart? Well, we're starting with nanos, which are all the way down here. That's billionths. And then we're going to be ending up at deca, which is all the way up here. So first thing you want to do is go from your nano to the base unit. So we'll go from nano to liter. And then you want to go from your base unit up to deca. So we'll go from liter to deca. So those will be the two steps that we do. So if we kind of take a look at the problem, we'll take a look at the first part. You have 734,000 nanoliters. We'll draw our conversion factor line here. And we want nanoliters on the bottom so that they'll cancel out. And we want liters on the top. And then we want to say, okay, well, which one is bigger? Here's our base unit of liters. And then here's nano down here. Liters is higher up on the chart, so it's bigger. So since liters is the big one, we put a 1 up there for that. How many times bigger is the liter than the nano? Well, it's a billion times bigger, as we can see on the chart. So that's going to be 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. And this is kind of where scientific notation comes in. When you're dealing with huge numbers like this, it's very easy to add in an extra 0 or leave an extra 0 out. So an easier way to write this would be 1 times 10 to the negative 9th. Now I'm going to complete doing the problem with putting all the zeros in, because you may or may not be familiar with scientific notation. I'll put a little tag up in the video here. If you are not familiar with scientific notation and want to kind of have a video on that, I'll put a tag up there so you can watch that video. But eventually, all of our equations that we do, we're going to just do in scientific notation, because we're not going to want to be dealing with all these zeros. And there are lots of times in chemistry where you're dealing with either huge numbers or super tiny numbers, and it's much more convenient to write them in scientific notation than with all the zeros. Now for this one, to just finish it off, we'll do it the tedious way and we'll keep all the zeros in there, but do realize that it is much more convenient and much more effective to do this in scientific notation. Okay, so now we have it set up so that the nanoliters and nanoliters will cancel out, and then you multiply across. So we're going to take 734,000 times 1, which gives us just 734,000. And then we're going to take that 734,000 and we're going to divide it by a billion. So if we take 734,000 and we divide it by a billion, and if you're typing those numbers into your calculator, you can see that it is very easy. All you got to do is just miss hitting the button once, and it's going to give you the wrong answer because you got to type in so many zeros. But if we do this, we're going to get 0.0003734. 0.0003734. And again, if you wanted to write this in scientific notation, that would be 7.34 times 10 to the 1, 2, 3, 4, negative fourth. And the unit that we're going to have is liters. And again, in my future videos, most of what I'll be writing is in scientific notation, but since this is still a relatively beginner video, we'll just keep the whole numbers on there. So now this still isn't our final answer. We've converted our nanoliters into liters, but now we have to convert our liters into decaliters. So let's take our liters, our 0.0007334 liters, and we'll draw our conversion factor line down there. Put liters on the bottom so they cancel out. And then we want to go to decaliters, so that's DA is the abbreviation, decaliters. Which one is the larger one? Well, if we take a look for here, we see that here's the base unit, liters. Decaliters is 10 times bigger. Deca is higher up on the chart, so it's the bigger one. So since decaliters is the bigger one, we put a 1 there. How many times bigger is it? 10. So for liters, we need 10 liters for every 1 decaliter. We'll then do what we've always been doing for the factor label. We'll multiply across and divide up. Hopefully this is getting more second nature to you when you set the problems up. We can see that the liters and the liters cancel out. So we have to take 0.000734, multiply it by 1, which just gives us the same thing, 0.000734, and then divide by 10. And if you divide by 10, it actually puts another 0 in, so we'd have 0.000734, and the units on that would be a decaliter. And that would be our final answer for the problem. And again, if you wanted to write that in scientific notation, that would be 7.34 times 10, and then you go 1, 2, 3, 4, 5, negative 5 decaliters. Again, that's a much more convenient way to write the answer, but we did it all out with all the digits for this one, just in case you're not familiar with the scientific notation. All right, well, that's the end of the video on looking at a little bit more advanced metric conversions when you're going from a non-base unit to another non-base unit. The next video is going to take a look at English to English conversion. So if you're in the English system, how to convert from, say, miles to inches. And that's just kind of leading us into the real important conversion, which is being able to convert from the English system into the metric system and vice versa. So if you're interested in those videos, you can take a look at the tags up at the end of the slide here and move on to them. I hope you learned something, and I'll talk to you later. Goodbye.